Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. Miniature machines are attracting a lot of interest in applications such as medicine and robotics, but there is often a trade-off in the properties of the materials used to construct them. They can either be soft-bodied with a limited ability to move, or they're fairly stiff and mobile, but unable to significantly change their rigidity. A soft, low-rigidity body is vital if you want to adapt your miniature machine to a variety of applications or a changing environment. Research involving Sun Yat-sen University and Zhejiang University in China, as well as Carnegie Mellon University, has overcome this limitation by drawing inspiration from a marine organism known as the sea cucumber. The sea cucumber has an impressive ability to dramatically change its stiffness, a feat that has now been imparted to a low melting point metal embedded with ferromagnetic microparticles. The key to this shape-changing mechanism is the application of an alternating magnetic field that causes the metal to heat up. Carmel Majidi leads the Soft Machines Lab at Carnegie Mellon University.
We use gallium that has a melting point just a little bit above room temperature. We apply this alternating magnetic field that induces an electrical current into the material through electromagnetic induction. And then that current basically is what heats up the metal to elevate past its melting point, and then we get this phase change.
Electromagnetic induction leads to dual heating, which works very well in miniature machines that are a few millimeters or centimeters in size. Different shapes can be achieved by casting the liquid metal in a mold.
In addition to using magnetic field to induce that phase change, we can also use it to get the machine to move.
The researchers cast a tiny humanoid figure that could melt through bars and then reform by flowing into a mold before solidifying. The machine moves slowly in its liquid form, but is much faster when it's solid. The solid form is stiff enough that the tiny figure can effectively jump and stand upright again. The solid form can also manipulate small objects. And the machine is incredibly versatile. In medical applications, a magnetic field could be applied in a similar way to how an MRI is performed. The research team showed how the miniature machine can be used for drug delivery or for removing foreign bodies from organs. In other applications, they showed that it can mechanically repair structures or solder electronics, which leads to applications in repairable soft robotics.
There's long been interest in using these magnetic microrobots for applications in medicine. This does tie into this broader effort towards building soft robots that better mimic natural biological organisms.
This work was published in a recent issue of Matter. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.